Welcome back to Anatomy and Physiology, chapters 13 and 14. This is video number 10. So we are going to begin looking at three different reflexes in the body. And the first one is the stretch reflex. So the stretch reflex is, again, for protection. Most of these reflexes are to protect our body. So this is protection against overstretch of a muscle. And this is the one that is commonly done in the doctor's office with a reflex hammer. So this is the one where they tap right below your kneecap and it causes your foot to move forward. So we end up looking at how the anatomy influences this reaction. So at the top of our leg, we have the quadriceps femoris muscle, which is an extensor. And there's a very long tendon that comes down from the muscle that goes over top of the kneecap called the patellar tendon. And the patellar tendon is attached to the patella, and so is the patellar ligament. So these two kind of mesh together over top of the kneecap, and we end up with the patellar ligament going down and then inserting onto the tibia. Basically on the front, there's a little knob that it attaches to or build up a bone. So the object is to hit that hammer and stretch that ligament. By stretching a ligament, you're pulling on the muscle. So inside of the muscle are little tiny wee sensory organs called muscle spindles. And that is shown over here. And I'm just going to zoom down in here so we can look at this a little bit better. So this muscle spindle is a sensory receptor. And in here we have 3 to 10 specialized muscle fibers. That are contractible or contractile at the ends. So as you can see, we have a lot of nerve endings, motor and sensory, that are wrapped around these specialized cells. So we're going to go along and we're going to say what is happening in all 4 of these spaces, and we're just going to write them down up here. So at number one was the muscle spindle. At number 1, the muscle stretches. And that is due to the hammer, the reflex hammer hitting the patellar ligament, and it causes it to pull the kneecap down, which pulls on the patellar tendon, which then stretches the quadriceps femoris muscle. Well, if you stretch the muscle, we stretch the muscle spindle, which in turn generates an action potential. Since we have those nerve endings in there, that stretching of the muscle spindle, since it's connected to the neurons, causes a change in the voltage, and we end up with a reversal of the voltage, and we depolarize. So an AP is generated. In the sensory neuron when threshold is reached. Now, that happens here. Now we know that the sensory neuron is coming up, and that sensory neuron is going into the dorsal root, and then as you trace it, right here, we have divergence. So number 2, the AP travels along the sensory neuron through saltatory conduction into the dorsal root. Now, if you look here, there is no interneuron. That means that this is going to be a very, very quick reflex because it doesn't have to relay that message. So we're talking a few milliseconds quicker. But we also have right here convergence. So for number 3, the action potential diverges. So we go to the brain and then we synapse with a motor neuron. We also have convergence with a descending axon from the brain. And it's basically going to reinforce this. So an AP is generated in the motor neuron. So basically the brain is made aware that something is happening, and it can help, especially if this is going to damage something, it can reinforce this movement. And our last thing that happens is AP travels along the motor neuron via saltatory conduction to the muscle, which is our effector organ in this case, and we end up with movement. So we end up moving that muscle and contracting it, which extends this. So if you contract this muscle, it pulls it up and the knee moves, or the leg moves upward. So we contract this muscle, it shortens that, and the movement is upward.